In this video, I'm going to teach you about residuals, what they are, and how you display them. Let's start with the definition. The definition of a residual is the vertical distance an actual data point is from the predicted value on a line of best fit. It sounds really wordy, but let me help you understand it with some pictures. So I've got two examples here of some data, both of them scatter plots. And what I want you to see right this minute are my actual data points. So these black dots are considered actual data points. This is actual. All of these are actual data points. When I talk about a predicted value, I need to look at a line of best fit first. So I'm going to draw a line of best fit on both of these graphs. Let's start with this one here. Remember, your line of best fit should fit the data in such a way that it's passing through as many points as possible, keeping an equal number on both sides of your line, those points that are not on the line. This is a tough one here. I just put these dots on my coordinate plane. Let's go with this. Looks okay. I've got 1, 2, 3 dots below the line. I've got 1, 2, 3, almost 4 dots above the line. So I think it's pretty good. This line is going to be considered my line of best fit or my trend line. What this line does is helps me predict values. So when I make reference to predicted values, this is what we mean. Let's look at when x is 5. When x is 5, the predicted value is 4.8-ish, maybe 4.9. But the actual value of data that was described is 6. So when x is 5, the predicted value is about 4.8, but the actual value is 6. Keep in mind, a line of best fit just helps you make predictions for those data points you can't see or those data points you don't have. Now I'm going to draw my line of best fit in the second example, and you're going to see that my line of best fit is going to hit every point. Now I did this on purpose because I wanted you to see something with respect to the idea of a residual, a leftover amount from the actual data points to the predicted data points. In my first example, since my line doesn't pass through every point, here's what we mean by this concept of residual. When x is a 1, the actual data point is about 1 unit away from the predicted line of best fit. I would say this point has a residual of 1, a leftover distance, a separate amount from the actual amount. When x is 2, this dot right here, an actual value, is a little bit below my predicted value, so I'm going to say it has a residual of negative, this is tough, it's about 1/4 of a unit away from the line, so negative 0.25. What you're doing is just trying to describe the distance each point is from the predicted value. Let's look at when x is 4. When x is 4, the actual value is 2, but the predicted value is way up here. So how far is this dot from the actual or from the predicted line? It is about 2, maybe 2.2 units away. So it's about 2.2 units below the line of best fit. I'm going to put a negative 2.2. So every one of these dots, well, not every one, but most of the points, the actual data points in my example 1 are a little off of my line of best fit. These orange distances are called residuals. In example 2, you'll notice all of my dots are on my predicted line or on my line of best fit, so I have no residual values. It's good to have no residual values. When you have no residual values, you know your line of best fit is spot on. All right, let me talk a little bit more about line of best fit, and then I'll finish the thought with residuals. So the line of best fit for each one of these has an equation that will use to make predictions for values. On this graph right here, my line of best fit, since it's a linear pattern, it's a line, I'm going to use my linear equation, y equals mx plus b. My slope appears to be going up 1 or up a half over 1, up a half of a unit over 1, so its equation is 0.5 times x. My y-intercept appears to be 1.5. And I'm going to talk to you about correlation coefficient. Since every single one of these points is on my predicted line, my correlation coefficient, remember my R value, is equal to 1. This line is spot on with respect to making a prediction for any of the points in that data set. This line over here has a regression equation. It's also linear. Its slope is 0.65. I did this on the calculator a few minutes ago, so its slope is up 65 or up 0.65 units over 1, and it's looks like its y-intercept is approximately 1.5 also. Now, when I did the correlation coefficient calculation on my calculator, it gave me a correlation coefficient value of 0.84. 0.84 is a pretty strong correlation relationship. That means this line of best fit pretty tightly fits this data. Not 100%. This would be 100% on. This is not quite on. So as far as a correlation coefficient goes, you want your correlation coefficient to be a 1. You want your residual values to be 0. So I'm going to write that down here. You want your residuals to equal 0. That's a good thing. You want your correlation coefficient to be a 1. That's a good thing. And the reason I'm saying it's a good thing, it just means your line of best fit, your trend line, is spot on. Okay, something else you can do with respect to residuals is to show them individually in its own residual plot. So that's what I'm going to show you next. A residual plot shows each residual value related to each x value. Now, I've already got the plot started for both of these graphs. I'm going to show you what the residual plot would look like with respect to the original data set. So I'm going to start with example 1, and I'm going to show you that when x is a 1, this is still my x-axis. My y-axis now is going to represent my residual values. That's why we're calling it a residual plot. So these are still my x values in the data set, but vertically I'll be plotting how far away these dots are from the trend line. So when x is 1, I have an actual data point that is about 1 unit away from the trend line. So this would be like my trend line. That point is 1 unit away from when x is 0. When x is 1. When x is 2, see that dot right there? Doesn't it look like it's just slightly off the line? Like approximately, and this is an approximation for me, about 1/4. So I'm going to say when x is 2, we're about 1/4 of a point off the line. So that would be about right there. When x is 3, we've got a point that looks to be about 1/2 of a unit off the line. So when x is 3, that residual is 1/2 a unit away from my trend line. When x is 4, remember I did this one earlier, it's negative 2.2. So when x is 4, we are a little more than 2 units away from my trend line. When x is a 5, our predicted value is a 6. It's about 1, maybe 1.25 units away from the trend line. So when x is 5, 1.25 away. When x is 6, we're about 1/2 of a unit down. So I'm going to go 1/2 a unit down when x is 6. When x is 7, oh, we're so close. It's just barely off the trend line. So I'm going to just take it barely off. And then 8, closer still. This is what you call a residual plot. I have just plotted the residual distances of these data points, the actual points. Now, what would it look like for my example 2 when my trend line passed through all of the actual data points? Well, then I would say this point, when x is 0, has a residual of 0. This point has a residual of 0. That point has a residual of 0, 0, 0, 0. They are all spot on. So when x is a 1, we had a data point that was right on the line. It had a residual value of 0. When x was 2, residual 0. When x was 3, all of them were right on the trend line. So I just wanted you to see, what does it look like? What does the residual plot look like when your data is spot on, meaning you have a regression equation that has a correlation coefficient of 1. That means it matches perfectly. When that happens, all of your residual values will be 0. Residuals are all 0. That's a good thing. When your residuals aren't all 0, you want them as close to 0 as possible. So this is just showing you that all of the residual values are pretty close to your trend line. So I hope that helps you understand what a residual is. It's just the distance that your actual points are from your predicted line. And I hope you understand how it relates to correlation coefficient. So remember, you want your correlation coefficient to be a 1. That means your line of best fit is spot on. And you want your residual values to be equal to 0, or as close to 0 as possible.